Hello everyone, and welcome to the ccubed channel. This is a GCSE Maths Foundation video, so this is a Tier 1 video, where we'll be covering the basics of algebra. So we're kind of doing an introduction to algebra, introduction to different kinds of variables and different kinds of expressions. Today's topic, we are focusing on simplifying expressions, so we're going to be learning about what the expressions are, what variables are, etc. We've got different kinds of examples here as to what we'll be covering later on in this video. So, to begin with, variables. What are they? Well, a variable is basically an unknown number, so it's essentially represented by a letter. In most cases, you would use a letter. So, for example, we have things like x. Don't mind my handwriting, and this is quite bad, but you know, you'll be able to kind of make out what I'm writing. So we have x, for example. We also have y, and we also have z. There's three examples of, well, the three common examples you see for variables. So each of these could represent any number. So you could say x could be 1, or it could be 2, 3, 5, 10, 50, you know. It could be anything, and it's just unknown. We don't know, so we just label them as letters. Now, obviously, they're not just x, y, and z. It can be any letter. You can have it as A, B, you know, you can even have it as T, P, you know, anything like that. You can even have them from different alphabets. So commonly, the Greek alphabet is used as well. And we'll see this more later on when we get into more advanced maths. We won't see this too much in GCSE, but especially in A-level, and most definitely at university levels, you would see the inclusion of the Greek alphabet for variables. You see things like alpha, you see things like gamma, you know, you have all these kind of things. You got epsilon as well, you know, all these kind of letters. But basically, what I'm trying to say is anything can be used to represent a number. So, with variables, we can in fact combine them. So, there are 4 different ways we can combine variables. As we know, we have the 4 basic operations, which is addition, subtraction, multiplication, and division. So, we can combine 2 different variables, let's say x and y, and what we can do, we can just combine them in the 4 different ways. So, x plus y, this is addition, so just leave it be. X minus y, this is subtraction, again we leave it be. X times y, now in algebra, most maths, you usually do not put this multiplication symbol here for multiplying variables together. Now in maths we try to be very effective, try to be quite, I guess you could say, lazy. But you know, we try to make things as elegant to read as possible, make it very easy to read. So to symbolize multiplying variables, you could just say x, y. So this is exactly the same as x times y. It's just xy. So you don't need to put the multiply symbol there, you know. And this can apply with any combination of numbers and variables together. So that's something to keep in mind there. Now, as for x divided by y, again, you don't need to have this division symbol here to make it more elegant, make it more easier to read. You can just do x over y. That's another one you can use. So, we have x divided by y, and that can be rewritten as x over y. And this is more of the common standard method of, you know, writing division. So this is what we'll be seeing more. And this applies for, you know, numbers and variables, or a mixture of both. So this is a fractional form, we could say. So with that in mind, we can now go into something which is expressions. So an expression is a combination of numbers and or variables containing at least one operator. So we could use either addition, subtraction, multiplication, or division. And we have 3 examples here where they utilize, well, we can see all 4 being utilized. So we have the first one here, 2x plus 3. Okay, that's cool. So what we have here, remember what we said about multiplication, is that we omit the multiplication symbol. So this is actually 2 times x plus 3. And then you read it as 2x plus 3. So that's an expression, it's just a sentence in a way. So for the second one, same thing, same deal. You have 6 multiplied by y minus 2. So you'd read it as 6y minus 2. Simple as that. And then for the last one, remember, we recall with division, this can be written as 2 divided by p, but we just say as 2 over p. So these are examples of expressions. These are just sentences, I guess you could say. Sentences or combinations of different kinds of numbers and variables, or they could just be numbers only or variables only. Doesn't really matter, as long as there's some kind of operator. So we could take this a step further now, and we can see, what about expressions that have the same variable? So we call these like terms. Now, something I have not mentioned here is that in each expression, so we'll go back for a second, in each expression, each of these separate entities here, these are called terms. So anything separated out by by an operator are terms. So here 2x is a term, here 3 is a term, and then here 6y is a term, and here 2 is a term, and then here 2 is a term. Actually, my bad. The entire thing is a term here actually, because it's not it's not separated by plus or minus. Okay, so going back to like terms then, what we have here is that terms of an expression that have the same variable are basically like terms. So in this case, we can see you have 2x plus 3x, both include an x in them, so these are like. They're like terms, because they contain the same, kind of multiple. And the same can be said for y. Here, 5y minus 2y. The y's here appear in both terms, and so they're like terms. And then we can say the same for z. 3z plus 1z minus 2z. Now, a thing to note here is when you have when you have 1z in this situation, you can actually just simply write this as z on its own. Because, you see, this is basically just 1 times z, and we know anything multiplied by 1 is just itself. So you don't even need the 1z, you could just leave it as z. So that's something to keep in mind when it comes to this. Okay, so let's go ahead and actually simplify these out now. These 3 examples, I should say. So, when you have like terms, this means that you can in fact actually add them together, or you can perform the operations on them. So, for example, we have 2x plus 3x, and this is equal to 5x. Now the reason for this is because the like terms contain both an x, and so all you have to do is you just have 2 plus 3, right? So you get 5x. And obviously the x has to stay there as well. The x stays the same, but you just add the numbers together. And then when it comes to subtracting, again, because they're all like terms here, you just do 5 minus 2. And so you get 3y. Now for the last one, you can see that z appears in all 3 cases. So what we can do is we do 3z plus 1z, which is 4z, minus 2z, which is 2z. So the solution here is 2z. Remember, we just do 3 plus 1 minus 2, which is just 2. And then you just include the z at the end. So that's what we get. Now, the reason why this works, it can be explained down here with this little short example. So, let's say in this case we make one of the variables 2. So we actually now know, let's say, we now know that x is equal to 2, let's say, for a different expression. So the expression in this case would be x plus 5x. Right? Now remember, when you have the brackets like this, I should add, this is another way of saying multiply. So we got 5 and then brackets 2 brackets. That just means 5 times 2. So that's another way of writing it. Just to, keep that in mind. And then on this side, 6 times 2, if we make x equal to 2, then this is just quite simply 6x. Now we can see at the top, by using the rules we learn here, x plus 5x is equal to 6x. Because we've got 1x plus 5x n is equal to 6x. 1 plus 5 is 6, and then the x stays the same. So we're going to see why this works now. If we set x equal to 2 in this situation, then we would, let's actually calculate what this is. So 5 times 2 is 10. And we got 2 here, so 2 plus 10 is equal to, I should actually, yeah, is equal to 12. Right? And then 6 times 2 here is also equal to 12. So this pretty much just shows that these two are actually the same. And so this just proves that this equality works. You can see it works up here, and you can see it works down there. So that's why it works. And this can be applied to any kind of, well, any situation with like terms. Okay, so what about multiplying? Well, in this situation, we have x times x. So we said before that when you multiply terms together, when you multiply different kinds of variables, we see that, x times y is equal to xy. So in this situation, we would have x, right? So it's just x multiplied by itself. Now there's a quicker way of writing this, which is quite simply x squared. Now the x squared is simply because it's x multiplied by itself. Now a quick example to show that this works, let's consider 3, right? 3 times 3 we know is 9. And that is also equal to 3 squared. So you can see the equality here that 3 times 3 is equal to 3 squared. And so we have x times x is equal to x squared. And that works for everything. Now you can also increase the amount of x's you multiply with. So in this case we have x times x times x. So you can probably make a guess already. You can assume that it is probably going to be x cubed. And the reason is because we have 3 x's here that we're multiplying with, and here we had 2. And again, this works because you would have 3 times 3 times 3, which is 27, and that is also equal to 3 cubed. So this works as well. And then you can keep this going. If you have 4 x's, then it will be x to the power of 4, and then 5 will be x to the power of 5, etc. So it works. It just keeps going like that. Okay. So let's do a quick example down here now, where we have to simplify this. We have to multiply like terms together. So 5t and 2t are like terms. So what you get is, what we do actually is, you can do 5 multiplied by 2. And in this case we would see this to be 10. And then t times t is t squared. So we just do them separately here. We multiply the numbers first, and then we multiply the t's after, so we get 10t squared. And that's quite simply the method of doing this. This is pretty much a standard procedure, and there's nothing really different here. Okay, so now we can go ahead and simplify actual expressions now. So we've got 3 examples coming up here. We're just going to go ahead and simplify them. So what we're going to do, now I'm just shifting through here just to quickly remind myself. Okay, so what we're going to be doing here is we're going to go ahead and simplify this out. So remember what we said earlier, we can add like terms together. 2x plus 3x is 5x. So let's go ahead and use this procedure here. So we're going to, now what we want to do first, what I always do is, well, it would be, initially you don't have to do this step, but starting off it would be very good to do this. So we're going to group up all the like terms together. So let's do 2x plus x plus 3y. So we just group them out. We just move the x over to here, because you can do this. Doesn't matter what order it's in when it's all pluses like this. So this is completely fine. You're allowed to do this. And so what we could do now, we could just simply add up these together. So we're going to be left with 3x plus 3y. And now these two are not like terms, so you could just leave them be, and that's it, simplified. Done. So let's do another example. 3x plus 4y plus z minus y plus 2x. So that's quite long, but we can simplify this. So again, let's go ahead and group up the like terms together. So we got 3x, oh that's a bad x, but you get the idea, plus 2x plus 4y minus y plus z. Okay, so to quickly see what I've done here, so I've moved the 2x to here, right? So we got 3x plus 2x, and then we left the 4y, and then we moved the y over to here. Now remember, when you're grouping these together, it is always essential to keep in mind the sign. So what I've done when I moved this over, I didn't move over just the y, I moved over the minus y. Make sure that the minus sign actually comes along with it, which is why it's now here, and the z, and this entire portion here is moved over to here. It's essential to remember, keep the signs in mind, because they will make a massive difference, and later on in higher level maths and physics, this is an essential thing to keep in mind, because your values and answers will be completely wrong otherwise. So always remember that. So you might need some practice with this. So let's just go, now we have them all grouped up, I should say, we can go ahead and just simply add them up and, you know, do all that kind of thing now. So 3x plus 2x we know is 5x, and then 4y minus y is plus 3y, and then we just have a z at the end, so it's left like that. Done. And that's been simplified. So for the final example, we have this problem here, e plus 2e squared plus 2e minus e squared. Okay, so before we jump straight into this, I have to make a clarification here that yes, all the variables here are e, but we don't do 1 plus 2 plus 2 minus 1. We don't do that. And the reason here is because the e squared is different to the e, even though they are the same variable in a way, they have the same letter, but this square here makes a big difference. And the reason for this, I'm going to show in the example down here. So we've assumed that e is equal to 2 in this case. So we just quickly assume that e is equal to 2, yeah? So let's quickly just work this out here. So 2 squared is 4, and then 2 times 4 is 8, plus 2 is 10. Yeah? Okay, so we just established that. And now here we have 4, which is 2 squared, times by 3, and this is 12. Now you can see that 10 is not equal to 12, even though we just kind of assume that you can add, you know, these together, right? This is not allowed. You can't do that. So you because we just assume this is like e plus 2e squared. You can't say that 2 plus. I should actually. Oh, sorry about that. Let me just make that clarification real quick. E plus 2e squared is not equal to 3e squared. And likewise, it's not equal to 3e either. So you can't do this. They have to treat these as different individual variables. So with that in mind, let's quickly group these up now. So let's group all the e's together. Just do that, e plus 2e. And let's group up the e squares together. So we just got plus 2e squared minus there, just like that. And now we can just quickly do this. So we're going to get 3e plus e squared. And that is done. That's how you simplify that. So always remember to keep in mind, make sure you group all the like ones together. And if you have a case like this, make sure you keep in mind the index. So in this case it'll be e squared. So that is all I have to say for this. So for next time, we're going to go a bit further on with expressions, and we're going to go on into the indices laws, because the one we have not explored is situations such as this one here, with 10y over 5y. We haven't really explored. We've multiplied like terms, but you haven't divided them, and that will go into the next video where I'll be talking about the index laws and what to do when you have multiple indices together. So we're going to deal with that in the next video. But that's all I have to say on this, so thank you guys so much for watching, and I'll see you guys in the next video.